So hello guys, I hope you're doing fine and you're safe. So today I'm gonna show you how to optimize a simple C++ program using some optimizer in the compiler level. So this is a simple code to find out the Fibonacci of a number. So let's execute this code. As you can see, n equal to 5. So the Fibonacci of 5 is 8. So now if we want to know the execution time of the program, so we have to define a we have to include a library known as time.h, and we have to include, okay, so clock t is a data type which is specifically used for storing the raw processor time. So let's declare a variable known as start and end. And since our program is starting here, so start equal to clock. So what this function does is returns the raw value of the processor. So my program is ending here, so clock. Okay. So we need a variable to store the time taken. So let's name it as time taken, and I've used double because the time may be floating point. Okay, so now you have to cast the time taken. I mean the difference between the end and the start time, because it's returning the raw time of the processor, which is not, I mean, human readable. So we have to convert it into double, and we have to convert. I mean, we have to cast this macro known as clocks per second. This is a macro defined in the C++ library. So this is actually, as you can see, has defined clocks per second, clock t1000. This actually determines the time at which the clock is ticking per second. I mean, the number of times the clock is ticking per second. So let's see out the time taken. Let's write execution time. Sorry for my typing, it's not that good. Time taken. So now let's run the code and see. Yeah, you can see it's taken 0 seconds. I mean, it has taken a very short amount of time. So let's increase it to 30. You might be able to see the time now. Yeah, I can see it's 0.003 now. So let's increase it with 40. See now. Yeah, so it's 0.438. Since we'll optimize it, it's still very short time. So let's give it 45. So now you can see it take a bit of time. So yeah, the number is this. Since the number is so long, so I've used unsigned long int. If I use int, it would give me a negative, because int has a limit of, I think, this. So the execution time is 4.622 seconds. So we need to optimize this code. So before optimizing, let me explain you why this code is taking so much time. So there are two techniques to implement Fibonacci. One, as we know, by declaring variables f1 equal to 0, f2 is equal to 1, and so on like this. And the other, which most of us use, is using recursion. So recursion is a very important topic. I mean, it's very necessary. But recursion, as you know, if you're familiar with it, it creates an unnecessary memory known as, I mean, memory. Creates a type of recursion tree, which is, I mean, it's very unnecessary. It takes a lot of memory in the code. So what we are doing here is, let's optimize it. So we have used a pragma directive. So hash pragma, it's actually a directive in the C++ library. I mean, in the GCC library. Yeah. So you can use it either in C or C++. So pragma is actually a compile time directive, which is mainly used to turn on or off some features of the GCC compiler. So let's define GCC optimize. So if sorry, let's go to remember it's capital O and P. So what this is a directive. So what this does is it's actually optimizing the code at O2 level. So there are different levels of the GCC compiler. It's by default it's O0. I mean if you don't include this then it's O0 and different levels are O1, O2, O3. You can even optimize it by the size. It is size O fast and but most of us use O2 because it's more favorable. So one more thing, these optimization levels might not be working in some compilers. So just check if your compiler works in. Let's run the code. So now, yeah, you can see the now the time has reduced to 3.44 seconds. So using the GCC optimize. So now if we want to further optimize it, we have to do we cannot optimize more than this at the compiler level. Now we have to optimize. We want to further optimize. We have to optimize it at the processor level. That is at the system architecture level. So what we have to do is GCC target. We have to specifically target the processor here. So here AVX. Wait for a minute. I'll just explain you what is AVX, AVX2, and FMA. So let's run the code now. So yeah, you can see the time has reduced to 3 point. It is not reduced yet, but so I think it's still some problem. So let's run it again. So yeah, you can see the time is almost same. So I mean, let's increase the number and now let's try to execute it. So okay, let's take a bigger number here. Suppose we want to find the Fibonacci of 50. So let's comment out this and let's see the optimization at the O2 level first. Take a bit of time, so I'm pausing. So yeah, you can see using just the optimization level at O2, the execution time has been reduced to 37.3 seconds. So now let's include this hash pragma GCC target. So actually I forgot. Using if you want to target the optimization at the processor level, you need to use O fast. And now let's execute it. So yeah, you can see the execution time has not been reduced so much, but it's around 36.94 seconds. It has been reduced to approximately 1 second as compared to the O2 level optimization. Let me explain you what this GCC target AVX, AVX2 and FME means. So this line of code is actually targeting the execution time at the compiler processor level. So AVX, AVX2, FMN. These are all extensions to the 32-bit microprocessor of Intel and AMD, which were implemented in 2008 to speed up the execution of a program. Previously, 32-bit microprocessor just I mean processed information at 32-bit specifically only. So during 2008, Intel and AMD implemented AVX, which stands for Advanced Vector Extension, and FMA is actually Fast Multiply and Add. So these are extensions to the 32-bit microprocessor, which actually helps it to execute instructions at a faster rate in you can say at around 256 and 128 bit, but not by default. You have to specifically mention it, and as you can see I specifically mention it, and some programs even don't work after even if you mention this. So just check if your PC works. I mean, if your computer works at this TCC target. So yeah, that's it for today. So I hope you like this video, and I hope you are safe at home. Bye. Have a nice day.